You ready for the biggest one of them all? Class A. By the time we're done here, we will learn how to break Class A networks into multiple subnetworks based on specific requirements. And you know, when I say subnetworks, I really mean subnets. Everybody just talks about subnetting, subnet, but it's short for subnetworking, right? So let's dive in. Through an unfortunate discovery, Petropolis found that the Class B network would not support all regions, so they decided to redesign and segment into Class A 10.000/8 into at least 1,000 subnets. Pause for just a moment. Readdressing networks is a nightmare. So I know we're doing this as subnet examples. I just want to throw a little real world in there. You wouldn't roll out a whole Class B subnetting scheme and deploy, et cetera, and be like, let's not do that. Let's do class. Like you would be like, that would be like a multi-month year project to redo all your addressing. So just want to paint that reality before we dive in. So let's just say once they laid it out on paper, they decided not to do the Class B subnetting, right? So same situation, but now we want to break what? 10.0.0.0 into 1,000 subnets. Well, this could be a thing. Let's look at our 3 steps. Step 1, convert the number of networks to binary. So I'm going to take 1,000 equals, and again, remember, I'm not necessarily after the exact binary number. I just need to know how many bits do I need to reserve to get the number 1,000. Now, you and I both know that we can't get 1,000 with 8 bits. We have to go beyond that bit boundary. That's the leap I'm hoping that you'll take with me here. But we might as well start by laying out our 8 bits. 128, 64, 32, 16, 8, 4, 2, 1. But we got to go farther. 256 is 128 times 2. Still not enough. 512 is 256 times 2. Okay, still not enough. Let's find out. 1024. Oh, 512 is enough because this one went beyond. We can't subtract 1024 from 1000. So I can put a little dotted line right there because I know now it takes 8, 9, 10 bits to get the number 1000. I could figure out the rest of that number, but I really don't want to. I'm just going to say 10 bits because that's all I really need, because what I'm after in this whole scenario is to reserve the bits in the subnet mask and find my increment. Don't shortcut this. Draw out your 8 ones, that's the network bits, and then 24 zeros. Pop, just like that. These are all the host bits, and if you remember, a Class A address can have 16,777,200 and it's either 14 or 16. I can't remember off the top of my head. I think 14 hosts per network. That's insane. You would never have that. So we're going to sacrifice many of those host bits so that we can get at least 1,000 subnets out of this whole thing. How do we do it? We need 10 network bits. You start where the ones leave off and go 1, 2, 3, 4, 5, 6, 7, 8, dot 9, 10. The rest of these can remain on the host side. And yes, just glancing at that number of host bits, I know that we're probably going to have to subnet that further when we hand it out to the individual regions, because we're not going to have, unless we're like, equipping Goldfish with RFID that has IP addresses. I mean, we're not going to have that many addresses for every single pet store. So we know our subnet mask. In decimal, 255 dot, okay, we maxed out one of the octets, 255 dot, and it looks like 128 plus 64, that'd be 192.0, or if you're writing it in CIDR notation, remember that? It's a slash, that'd be 8, 16, 17, 18. Slash 18 would be a way of writing that. That's fantastic, but it doesn't mean anything to us as of yet until we take that lowest network bit and convert it back to a decimal number. Now again, we look at each one of these octets as its own set. Don't do something crazy like, 128, 256, 5. Don't do this right here. Every octet restarts the increment. So that is a 64, right? Okay, good so far. And I'm seeing where this is going, and I'm like, you'll get this. So we're going to go 10 dot what? So we started with 10.0.0.0. That's what we're given, /8. The increment is in the third octet, so it's going to be 10.0.0.0. I don't know why it took that long to write that one. We'll do 10.0.64.0. Did you get that? See how that works? 0.128.0. I want to keep going with this just for a second because I want you to see. So first off, let's fill in a couple end ranges, right? This will go to 10 dot what? 0.63.255 is the last IP address before I get to 64. This goes through 10.0.127.255. You getting this? Are you feeling it? Seeing how this works, right? Okay, let's keep going because I want you to see something. 10.0. Okay, 128 plus 64, that's 192.0. You can fill in end range if you'd like to, but let's do right here. What's the next? 10.0. Hang on. 190. What's it? 192 plus 64 equals 6. Be 5. Carry the 1. We're doomed. You can't have 256. Petropolis goes down in flames. You can't have 256. It doesn't. Wait a second. Are you saying, Jeremy, that this is weird subnetting math? That's kind of what I'm saying. Watch this. 255. What's the last IP address that you would have before you got to 256? 10.0. Hang on. 255.255. Okay, so using an increment of 64, we essentially get 4 subnets before we, and I know you're like, we get more than that, right? Because we need at least 1,000. Yeah, absolutely. Before we go, okay, not going to do that. 1.0. Whoa. How did you get that? Well, again, in our weird subnetting math way, if I were to add an extra IP address, right? Again, it just kind of follows, right? It's like 0, carry the 1, because we can't go to 256. It'd be like, 0, carry the 1, and now we're I don't know if that helps you. That kind of makes sense in my head. But the fact is, that's going to be the next IP address because we can't have 256. So when you see it flip to 256, you just start this whole scheme over again. You're going to go to 64, and it drops off the bottom of the screen here. 128, 192, 2.0. Does that make sense? Make sense? So how many actual IP addresses do we get? Well, again, we know the formula for that, right? When I say IP addresses, I mean subnets. We're going to have our 10 network bits. So we know these are 2 to the power of 10. So to be to the power, or what am I saying? To the power of, the powers of 2. I'm sorry, I've been talking about subnetting too long. You get that, right? 2 to the power of 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 2 to the power of 10. So in reality, we wanted 1,000, but 10 bits gives us 1,024. And how would we find how many hosts per network we get? Well, that would be, again, 2 to the power of, what would that be? 8, 9. Whoa. You didn't see that, right? When you count zeros and talk at the same time, you end up with 9. So 8, 9, 10. Hang on, I got to make sure I didn't do that twice. Okay. 8, 9, 10, 11, 12, 13, 14. 2 to the power of 14 minus 2 broadcast network will give you how many hosts that you have. Now, chances are, if you are taking some kind of certification exam and having to do this, they're not going to ask you something. They know. It's like, okay, come on, you got to throw a man a bone. You can't do that, easily without a calculator. But using a calculator, you'd probably find, I don't know, what would that be? Like 30 some thousand. It'd be a lot. It'd be too much. And that's why this works well for a region. Remember our scenario here. We're trying to take this 10.0008, break it into 1,000 subnets, and then we can give it to Eugene and Tucson and Dallas and San Diego. And they can then subnet it further. They can just take that network bit further out and then use increments to assign to their individual stores. It's like, I don't know why Amway came into my mind. It's like a pyramid scheme, right? But you're allocating all these things just based on, all of the individual stores that need each one of those networks. That's it. That's subnetting. Now, there's more, and there's actually going to be more skills. This has been a skill solely focused on subnetting based on the required networks, and there's still more to do. I want to give you some exercises. I want to give you there is a I'll call it a dangerous increment. We'll talk about that in another video in this skill. But you've seen it all now. Class C, Class B, Class A. You've got subnetting based on the number of networks. Now you just need to work to solidify that skill to where you can just do this blindfolded. I hope you let the impact of what I just said soak in for a minute. You know how to do subnetting. Isn't that awesome? Good. Now we're just going to enrich that process even more as we get into the future skills on this. For now, I hope this has been informative for you, and I'd like to thank you for viewing.